Hey everybody, today we're going to be talking about a specific problem on the 2019 Spring Math MCAS release. So as before, if you haven't watched these before, I'm assuming though if you're at this one you have, there will be a link in the video description that'll take you right to the digital version of this test, which you should already have tried, honestly. Like you should try this problem on your own first and then watch this video. Now this one is a little different because the PDF I prepared before did not include the fourth part of this problem, so it's a separate PDF with just this problem. It's in the video description. So if you have the big packet from class, you're going to be missing the fourth part, although we did this in class together, that fourth part, because it's pretty crazy. So anyway, just as a heads up. All right, so let's jump right into it. So this question is 4 parts. A line and a parabola are graphed on a coordinate plane. The equation of the line and the equation of the parabola are shown in this table. So here's the equation of our line, y equals negative 3x plus 5. And the parabola, y equals negative x squared plus 2x plus 1. So part A is asking us to find the value of y for the line when x is equal to negative 4. Show or explain how you got your answer. Okay, so what we're going to do is essentially plug in negative 4 for x into our line equation. So we're going to write y equals negative 3x. And again, this will be typed into your entry box here, right? And this is why it's so important that you try this digitally, not just writing it down. This is something you do right while you're following along here, but you want to make sure you can get used to the format on the computer itself, which is that's why you should click on the link before. So hold on one second. Okay, so we're going to go ahead and plug in our x value, which is negative 4. So y equals negative 3 times negative 4 plus 5. And this is just going to, let me zoom in a little more so you can see this a little better. This is really just showing whether or not we know how to use order of operations, right? Do we know how to do this? So we're going to multiply before we add here. So negative 3 times negative 4 would be 12, and 12 plus 5 is 17. So x would be equal to 17. Okay. Pretty straightforward. Okay, so keep in mind, this part is worth just as much as the last part. So getting this is really important. You want to make sure you get these first 2 parts right. If you can get at least half of these 4 parters right, you're going to pass, no matter what. The likelihood of you failing the MCAS, if you can get at least half of the points on these 4 parters right, is extremely, extremely low. So as long as you get these first 2 parts right, you're good. You're golden. Okay. So let's look at the second part here. So what is the value for y of the parabola when x equals negative 4? Show or explain your answer. So it's similar, almost, basically the same thing as we just did, only we're going to be plugging in this quadratic equation. So I'm going to rewrite the equation here. So we're going to have y equals negative x squared plus 2x plus 1. And our x value is negative 4 again. So we're going to plug that in. So y equals, now this is where order of operations is very important. Negative, notice this negative sign is not squared with the x, so that's going to stay outside. Okay, that's important. Negative 4 squared plus 2 times negative 4 plus 1. So immediately right off the bat, I notice this part. This is where a lot of students will make a mistake. They either won't put parentheses here and it'll become 4 squared, and they'll just say, oh, there's 2 negatives. No. This is not being squared with the x, so this has to be thought of as outside of it, okay? So that is really, really important. That's where most students that got this problem wrong, I bet that's where they made the mistake. So let's follow our order of operations. So we're going to do negative 4 squared, which will be positive 16, but you have that negative sign waiting for it, so it's essentially going to become a negative 16. So 2 times negative 4 plus 1. So let's do negative times 16 is negative 16. Negative 16 is right here. Plus 2 times negative 4 plus 1. 2 times negative 4 is going to be negative 8. So negative 16 minus 8 plus 1. And now we're going to just go left to right with addition and subtraction. So negative 16 minus 8 would be negative 24. And plus 1 is negative 23. So y equals negative 23. I didn't write y equals each time. I guess I should do that. Okay, so again, on this problem, just pay close attention here. If you have a quadratic, there's a negative sign in front of it. Remember that's outside the parentheses. Take care of this first, then that's there. Okay, don't forget that. All right, part C. Now this one I'm probably going to use scrap paper just to fit it. Yeah, hold on a second here. That's not it. There we go. So, zoom out a little bit. The line and the parabola intersect at 2 points. The distance in units between the 2 points is represented by this expression. Simplify this expression to determine the distance in units between the 2 points. So we have to simplify this radical. Okay, so I'm going to rewrite this. This is where you would definitely write this on your scrap paper, as you would the others as well. But that's another thing too, guys. The previous ones we just did, you would want to write that down first in your scrap paper and then put it into the answer box. Don't try to just do it directly on the computer. If you do that, you're just asking for trouble. Okay. But if you're in my class, you've probably already been told that a billion times, so I'm sure we're good. So 4 minus 1, and then negative 7 minus 2. Okay, here we go. So order of operations, let's do the things inside the parentheses. So 4 minus 1 is 3. Okay. Let's cheat. Let's do this too. Why not? Negative 7 minus 2 is negative 9. And that's squared. So let's square these. So 3 squared is 9. And negative 9 squared is going to be positive 81. Because negative 9 times... That's not negative 9 times 2. Don't forget. That's not times 2. It's multiplied by itself. So negative 9 times itself is positive 81. Okay, so 9 times 81... Not times. 9 plus 81 is 90. Okay, so a lot of students would stop there. Don't, though, because it says simplify it, right? This is not the simplest version of it. We can actually start breaking down these radicals, right? So 9 times 10. You guys remember doing these? The old factor trees? 2 times 5. Okay, so we're going to write these all out. So it's going to be radical 3 times 2 times 5. So because this is a square root, we're looking for numbers that happen twice. We have 2 3's right here. All right. So we're going to cross those out, bring it on the outside. We're going to leave these in here, so 2 times 5 is 10. So 3 radical 10. Okay? But you'd have to show this work, so make sure you show this work again in the... You should have already done this, by the way. I'll say that again. People have a hard time using that digital format, that answer box. Get used to it. Definitely make sure you're familiarizing yourself with it. So when you go into the test, you're not like trying to fiddle around with it. It's not easy to use, okay? So, okay, now it's not going to be on this one. It's going to be right here. So this is the big nasty, right? This is the problem that is just mean. This is the one, like if you've ever seen Good Will Hunting, yeah, this is the problem the guy did on the board, okay? So the area and circumference of the region of the coordinate plane enclosed by the parabola and the line is represented in this expression. Okay, so this doesn't really matter. Okay, this preamble, it doesn't really matter. This is what matters. Simplify. So to simplify this expression, okay? So you have to take this whole thing and simplify it. So I'm going to walk you through it. The good news is this. You don't need to get this right to pass the MCAS. This is like, if you get the 4 parts on a 4-parter, yeah, you're good, but you don't need to. You want to try, obviously, but don't lose any sleep if this is going to like just seem like it's crazy, because it is crazy. This problem is kind of crazy, but again, you don't have to get it right, but you can if you just take your time and watch. This really just requires you to go very slowly, right? And again, this would be on the non-calculator section, right? Unless you have a calculator as an accommodation. So when I first did this, myself and Mr. Mikulusky had like a math off, because that's what dorky math guys do. We had a math off, right? And we challenged each other to get this problem correctly done first. He went faster than me. I was going slower. And Mr. Mikulusky, if you're watching this, I'm going to talk some trash. He was making fun of me, and then I made a mistake, but then he realized he made the same mistake. He went back to fix it, but then I fixed it, and I got it right before him. So yeah, if you see Mr. M in the hallway, you ask him how it went. Anyway, so let's go ahead and start solving this. So there's a whole lot of things going on here. Let's work on these parentheses first. So let's look at this. Let's simplify this. So 1 to the 3rd power, right? Well, and by the way, we're going to cheat here. We're not going to do each step each time because it would literally take 5 pieces of paper. So yeah. So 1 to the 3rd power is going to be 1. This negative sign is not inside parentheses with the 1, so we don't have to worry about cubing that, okay? So we're going to do that. So that's going to be 1. We still have a negative sign, so negative 1/3. Okay? And then we can do this. I'm going to circle what we're doing first. So we have 1 squared. And you need to do that before you multiply. So exponents come before multiplication. So 1 squared is 1. So plus 5 times 1 over 2. Another thing to be wary of too when you do this is make sure when you write it down, you don't make any mistakes rewriting it. It's very easy to do that with a problem this big. And then we can do this too. I know technically it's not an exponent, but it's not going to affect our answer in a negative way, so I'm going to do that. So negative 4 times 1 is going to be negative 4. Okay. Somewhere there's a math teacher watching this asking, why did he do it out of order? Well, save time and it's not going to affect our answer. We can do this too, actually. It's not going to affect our answer negatively. So negative 4 times 4 is negative 16. Okay. So let's look at this. We can simplify this a little bit. Let's do the exponent. 4 squared is going to be 6. That's not 8. That's 4 times 4, so it's 16. So 5 times 16 over 2 plus. And again, 4 to the 3rd power, this negative sign is not being cubed with it. So 4 times 4 is 16. 16 times 4 is 64. Yeah, 64 over 3. Yep. And again, this is without a calculator, so not sure. Write it out, right? Just test it. The way I did that is, so 4 times 4 is 16, and this, I need 4 of those. Well, I know it was 2 times 16 is 32, then 2 of that is 64. Okay, so we got a lot of progress done there, so now we can simplify it a little bit more. I'm going to leave this as an improper fraction. You'll see why. This problem is a lot easier if you leave things as improper fractions. Let's do this. 5 times 16, 5 times 6 is 30, carry the 3 is going to be 80, so plus 80 over 2. Negative 16 is going to stay as is. Negative 1/3 is going to stay as is. 5 times 1, that's going to be 5. Again, remember, this is worth just as many points as the first part, which you did like that. So this isn't really worth getting too stressed out about. And then minus 4. Okay, so we're going to now focus on getting this simplified. We want them to all have the same denominator. So this currently has a denominator 1. So 3, 2, lowest common denominator would be 6. So I'm going to write that over here on the side to show how I did that. So negative 1/3. I'm going to multiply the top and bottom by 2. And that's going to give us negative 2 over 6. And then this one, 5 over 2. We're going to multiply this by 3 because again we want the bottom to be 6. So top and bottom by 3. This would be 15 over 6. And then negative 4 over 1. We have to multiply top and bottom by 6 to make the denominator 6. Okay. So that's going to be negative 24 over 6. Okay, so let's rewrite all that. So negative 2/6. And then plus 15/6 and minus 24/6. So that's all that. I'm going to write all this again. I'm not going to. I am going to simplify that. 80 over 2 is going to be 40. 40, and then we'll leave that as an improper fraction. Okay. Now let's combine these. So negative 2 plus 15 is 13. 13. Take away 24 would be negative 11, I think. Let's just double check that. So 24 minus 13, 11, negative 11. So negative 11 sixteenths, sixths rather, and minus. And let's do this. So I'm actually going to convert these to, no, I'm going to change this to a mixed number for now, then go back to an improper fraction. Though I said I wouldn't do that. Am I? No, I'm going to make them all fractions this time. I'm going to do this a little differently than I did the other day. So we're going to change this to thirds and this to thirds. I'm having second thoughts. Yeah, I'll do it. Why not? So 40 over 1 times 3 over 3, 120 over 3. So negative 64 over 3 and positive 120 over 3. Let's change this to thirds. So 16 over 1, negative 16 over 1 times 3. And that is 48 over 3, I believe. 32, 48, yeah. So negative 48 over 3. And then this is going to become plus. So we're going to, now we're going to combine these. So negative 64 plus 120 would be what, 56? Yeah, 56. 56 over 3 minus 48 over 3 plus 11 over 6. And then 56 minus 48 would be 8 over 3 plus 11 over 6. Let's change this to sixths. So 16 sixths plus 11 sixths would be 27 sixths. This is different than I did it, but I actually think it's a little easier. So let's change that to a mixed number. So 27 divided by 6 would be 4 and 3 sixths, which is 4 1/2. Okay, so I did that differently this time. I don't know if that's more confusing or less confusing. It's probably more, knowing my luck. So, yeah, here's the deal with this problem. One, it's really long. It's really, really long, okay? I kind of wish they just had something like the power of 0 at some point to make this just reasonable, but yeah, it's also requiring us to work with a lot of fractions, mixed numbers, both proper and improper fractions. You can change these to mixed numbers, but I don't think it makes it easier. You don't want to change this to decimals. That's where you're going to run into trouble. So I think most students would be okay until they get to this part. And I think that's where a lot of students run into trouble because we have a general aversion to fractions. So I'm going to leave this on screen so you can see how I did this. And there's multiple ways of solving this. This is actually different than the way I solved it earlier. So anyway, I hope that sheds some light. And again, I don't want this part to worry you because it's just an extremely, extremely long and arduous way of getting a single point. So again, right, that's worth 1 point. These two are worth double that. So don't freak out if you can't get that done because we can all do these two, and that's worth twice as much as that one piece. So don't sweat it. Okay. So that's going to be it for number 9. I'll try to get a few more problems up before vacation. Thanks, guys.